A list is an object in Python, just like everything is an object in Python. And like most objects, it has methods to manipulate the data. Here's a list. These are the items I found in my fruit bowl, sort of an inventory. We've seen already that we could copy this list. Copy is a method of the list class, so since my fruit bowl is an instance of the list class, or an object made from that class, we can access that method and copy my fruit bowl into another bowl. Of course, as a copy, we can change my other bowl without affecting my fruit bowl. This type of copy is called a shallow copy because we're actually not making copies of all the individual objects inside. We're just copying the references. More on that later. We also saw that we can append a list. That's an in-place operation, meaning that it's going to change the existing object rather than make a new one. Another operation that's just like append is called extend. So supposing we went to the store and bought some more fruit, we could append these items one at a time into the fruit bowl, or we can extend the fruit bowl. We provide any iterable object as an argument, and all of the items in the iterable will be added to the list. And again, that happens in place. So we're actually changing my fruit bowl rather than creating a whole new object. There are a couple of other in-place things we can do. We can sort the list. In this case, the list gets sorted alphabetically. There are more complex ways that we can sort lists using something called a lambda function, but that's beyond the scope of this course. We can reverse a list in place. So we had it sorted, and now we have it sorted in reverse. It turns out there's an argument we could have used with sort called reverse equals true to make it sort in reverse. We've seen that we can find an item in a list using index. This doesn't do anything to the actual list, but returns an integer, and that integer tells you the position in the list of the item you searched for. In this case, there was more than one orange in the list. Python gave us the index of the first one that it found. We can remove an item from the list, and we see we have one fewer orange. It just went ahead and removed the first one. We saw that we can append to the end of a list, but we can also insert in the middle of the list. So if we want to now add a papaya as the second item in our list, of course that's in position 1, we see that papaya got put in the right place. Insert and remove are expensive functions because Python actually has to move every single item over to make room for the new item when you're inserting an item, or move every single item back when you remove an item. There's another data type called a linked list that overcomes this problem, and you'll learn about that in your next course. We can count how many oranges we have in our bowl. Let's see, at this point we should have 2 oranges in our bowl. We just tell Python the object we're looking for. And again, this doesn't do anything to the list, it just returns an integer, so we'll print that out. Notice I use the double quotes inside my F string, so I had to use the single quotes on the outside. And finally, we can clear a list. So in the end, we have an empty list. Keep all of these methods in mind. They're all very useful. They come up all the time, and they'll keep your code concise and compact.